Attention class of Vesco, come on and let's go. This ain't just spam, we're studying for our exam. It's up to you if you want to review, you want to learn about vectors, they're sweet like nectar. Go climb a tree, take a look at geometry, we're gonna break it down, spread the news around town, we will simplify so you can identify. First you need to know what sketch to show. 4 units right and 5 units up. Then make a dot and that's what's up. Now find the magnitude but don't get an attitude. Use this equation to get grades like an Asian. The answer is numerical but it's not a miracle. The answer is a scalar. Mix it up and you're a failure. To find the direction, make this connection. Use SOHCAHTOA and you're ready to go. Move on to the dot product but break for some hot pockets. The answer is numerical, but it ain't no miracle. The answer is a scalar. Mix it up and you get failure. Multiply the coefficients to be efficient. Then add them together, easy as a feather. Gotta find that angle, if not, you're in a tangle. Dot product over magnitude equals cosine theta. That may sound hard, but don't be a hater. That's a vector rap, now don't give us crap. We learned it from Billy, he ain't from Philly. He got a 4.0, so he has to know what we're talking about here. Now Frito, give me a beer.
Alright, the question asks, sketch and find the magnitude and direction of this vector here. To start off, we're going to find the magnitude, and you simply use the equation of magnitude, which is the square root of a squared plus b squared, or the coefficients squared, which equal square root of 4 squared plus 5 squared, which equals the square root of 41, which approximately is 6.4. Next, we're asked to find the direction of the vector. Here we have the graph of the vector, and we just simply need to find theta. And to do that, we use tangent, which is opposite over adjacent, 5 over 4. And to find the angle, you just do tangent inverse of 5 over 4, and that leads to approximately 51.39 degrees. And make sure your calculator is in degree mode for all this.
Alright, for this next example, we're going to find the dot product of two vectors. We're going to use u, which is 6, negative 1, and v, which is 2, 5. The dot product of two vectors isn't another vector like you might think. It's a scalar, which is just a number, like 8 or 7. To find the dot product, we multiply and add the coefficients of the vector. So 6 times 2 and negative 1 times 5, because as you can see over here, those are the x and y components of the vector. Obviously 6 times 2 is 12 and negative 1 times 5 is negative 5, which will be 12 minus 5. So obviously u dot v equals 7, because 12 minus 5 is 7, and it's a scalar, which is a number. Next we're going to learn how to find the angle between two vectors, in this case u and v. The equation is u dot v over the magnitude of u and the magnitude of v equals cosine theta. First you take u dot v, and u is 6, negative 1, and v is 2, 5, and you put that over the magnitude of u, which is square root of 6 squared plus 1 squared, times the magnitude of v, which is radical 2 squared plus 5 squared, and set that equal to cosine theta. The dot product is going to equal 7, as I mentioned earlier, and you're going to have that over the magnitudes multiplied, which is radical 37 times radical 29. Set that equal to cosine theta also. And then to find theta, we're going to do inverse of cosine of that final product there, which is 0.21369. So therefore theta equals 77.66. As you can see, the wind here we're experiencing in this hurricane on May 24th in Orange Park, Florida, is another real-world application of vectors. The wind's magnitude would be the speed it is going, and the direction would be whichever way it's blowing.
Another real-world application is cars. Notice how the car has a magnitude of 5 miles an hour and a direction of east.
One real-world application is throwing things at Ryan. The magnitude is the distance between us and him.
The direction is at Ryan.
Look like it hurt.
I gotta throw it over.
The Red Baron uses vectors when flying by using the head-to-tail method because he adds the wind vector to the direction in a vacuum. Even Casey Kane uses vectors while driving around a track at 200 miles an hour. The direction is always left. Sometimes. Captain Nemo applies vectors to his sailboat so he can do a similar method as a pilot. When the Joker is robbing a bank and running away from Batman, he's using a vector to know the direction and speed at which to run to escape the Cape Crusader.
Did anybody see that man driving?
What is he doing?
Okay, it was like this huge van with no doors. It's like this old white guy with like white hair and no shirt.
No, I didn't see that. The answer is numerical. Frito, you need to quit that. Don't your pizza rolls.
Yep. Say we go to McDonald's.
We ate all the pizza rolls, Frito.
This is McDonald's, not pizza
Ice
rolls.
cream. Let's eat all the ice cream. What is cookies?
Just cookies?
This cookie thing. Are you recording?
I'm gonna sit here and stand here for a picture. Let's all look stoned and creepy.
You're not looking stuck and creepy, Ryan.
I know. I'm looking stoned and creepy.
Let's all look stoned and creepy, man.
The two, but don't get an attitude. Down, smash them. Then add them together. Oh.
Oh, I wasn't recording.
Hey, don't be looking all over.
Hurricane on. Wait, what's the date? Cam, don't. Attention class of Vesco, come on and let's go. This ain't just spam we're studying for our exam. It's up to you if you want to review, you want to learn about vectors, they're sweet like nectar. Go climb a tree, take a look at geometry, we're gonna break it down, spread the news around town, we will simplify so you can identify. First you need to know what sketches show. 4 units right and 5 units up. Then make a dot and that's what's up. Now find the magnitude, but don't get an attitude. Use this equation to get grades like an Asian. The answer is numerical, but it's not a miracle. The answer is a scalar. Mix it up and you're a failure. To find the direction, make this connection. Use SOHCAHTOA and you're ready to go. Move